Hello, all. Myself, Purnima, Professor in Department of ENCE, SVCE, Bangalore. Today, I'll be continuing with the Embedded System Core. The Embedded System Core, as we have seen in earlier classes, it can be of the microprocessor or microcontroller, or it can be of the digital signal processor. When this digital signal processor is placed as a core in an embedded system or for the development of an embedded system, it is application specific or domain specific embedded system. Why this digital signal processor as a core, when it is incorporated in an embedded system, it is termed to be the domain specific embedded system. The reason is listed here, and let us discuss why this digital signal processor based embedded system is categorized as application specific or domain specific embedded system. This digital signal processor is a powerful special purpose available in 8-bit, 16-bit, 32-bit, which is designed specifically to meet the computational demands, such as wherever there is a power constraint in the today's embedded systems, such as audios or videos or in the communication applications, these digital signal processors plays an important crucial role. So since the digital signal processor, it is supports for the audio, video and communications, it is domain specific. See, this digital signal processor, whenever they are placed with the embedded system, always you can see that they are the processors which speeds up the execution faster 2 to 3 times compared to the general purpose microprocessors in signal processing applications. So hence DSPs plays a very important role when the real-time signals analysis is done. And another important factor related to the DSP, digital signal processors, is that always the algorithms we will be implementing in hardware whenever we go for DSP based system code or embedded system. Hence, always you can see the execution time or is more faster in DSP based embedded systems. Whereas this particular general purpose processors, if you look at, always these general purpose processors, when we make use in an embedded system building, the algorithms we will be implementing in firmware, a specific software. So hence, always the speed of the execution in such general purpose processor based embedded system, it depends on the clock which is associated or which is running the processor for all the computational tasks. So hence, always the general purpose processor's speed, it depends on the clock of the processor, and the program execution, always it is dependent on the clock. The another aspect, if you look at the digital signal processors, they are viewed as the microchips designed for high speed applications. So such as wherever you need to go for addition, subtraction, multiplication and division, computational operations, you can go for digital signal processors. The digital signal processors, how they are in architecture wise, they are differ. These two, digital signal processor based embedded systems will have the program memory, similarly the data memory, then computational engine it will have, IO units it will have. And majorly these digital signal processor based embedded systems, they are used for audio, videos and signal processing. Apart from that, most of the telecommunication industries and the multimedia applications, they are employing these digital signal processor based embedded system. So this is another type of embedded system we can have depending on what type of application we are going to make use. Next is, what is the RISC and CISC processor or controller is. Let us discuss what is a RISC, reduced instruction set computer, and complex instruction set computer. Depending on how the architecture internally has been designed, based on that the number of instructions, how they have been associated with the embedded system, there are two categories we can see. One is the RISC and the other one is the CISC. If you look at the processors or controllers, you can see there are quite a good number of processors which supports for RISC type of embedded system, and controllers or processors, even there are good number of processors or controllers they support for CISC architecture also. When the major differences between the reduced instruction set and the complex instruction set, if you are taking care, the very first difference is that in a reduced instruction set computers, the name itself, it suggests that there won't be many instructions, so therefore lesser number of instructions you can see in a reduced instruction set computers. In the complex instruction set computers, the large number of instruction sets which are available when an embedded system is considered. Here, the instruction pipelining and increased execution speed you can observe in the RISC-based processors. And here in CISC-based embedded systems, there is no pipelining architecture. What is pipelining? That I will be discussing in the next class. Another important difference is that this RISC processor will have the orthogonal instruction set. What do you mean by orthogonal instruction set? The RISC allows each instruction to operate only on any register and use any addressing mode. So each instruction can use any register and can be configured in any of the addressing modes. Whereas the CISC has got the non-orthogonal instruction set. What do you mean by that? It is the exactly opposite to that of orthogonal instruction set. That is what the RISC processor maintains. Here in this CISC, all the instructions are not allowed to operate on any register and use any addressing mode. Means a specific instruction will have a specific register and also a specific addressing mode. That is what non-orthogonal instruction set. So the instruction is very specific in the CISC processors. If you look at here, the operations are performed on registers only. The only memory operations which we can see are load and store. So most of the operations which will be performed in RISC processors on the registers. There are two instructions which supports for memory operations, that is load and store. Whereas in the CISC, the operations are performed on registers or memory depending on what type of instruction we will be using in the CISC processor. In the RISC, since reduced number of instructions and all the operations we will be performing on the registers only, there are large number of registers which are available in the RISC processors. The limited number of general processor purpose registers you can see in the CISC, because most of the operations in the CISC based computers or embedded systems we will depend on the memory, so therefore less number of registers you can see with the CISC processor. Here in the RISC processor, the programmer needs to write more code because lesser number of instructions, load and store instructions, only simple tasks to perform, many instructions we will be repetitively using in the RISC processors. in the CISC processors, the programmer can achieve a desired functionality with a single instruction. That is what you can see with a single instruction does multiple operations. For example, mul instruction, which can be used for mul AB. So, two register contents which are going to be fetched, and multiplication operation will be done, and the result goes back onto the AB registers in the CISC processes. The single instruction able to fetch the data, perform the operation, and store also it is taking care. But here, whenever that particular instruction has to be, multiplication operation task has to be done in this, first we have to load individually the constants or the variable values, and then multiplication operation, and storing also it has to be done through store instruction. That is the main difference in terms of the simple instruction, where one instruction, multiple operations in the CISC, a number of instructions to perform a single operation in the RISC. You can witness. If you go for the RISC, it is the instruction, always it is a single instruction of fixed length. Here the instructions which you can witness with the CISC processors are variable length instructions. Mean to say, there are some instructions which uses 2 bytes in the memory after decoding, and 4 bytes, 6 bytes, 8 bytes, and so on. Whereas here, when you look at here the RISC processors, most of the instructions will be of 1 byte or maximum of 2 byte. Beyond this, the decoding, when any instruction is done, it won't cross. So the limitation with the memory in case of fixed length instructions. The RISC processor uses the less silicon usage and less number of pins. So here the complex instruction set, because here the complexity associated during the fabrication of the chip itself or CPU itself, it requires more silicon, and additional decoder logic also it is required to implement the complex instructions decoding. The all CISC processors, how do we categorize? It is all the RISC processors we categorize under Harvard architecture. The CISC processors, there are few CISC processors which are categorized under Harvard architecture, and few are categorized under von Neumann architecture. Thank you. I'll stop at this point.